Hi everyone, welcome to another tutorial of mine, and this one today is based on the hypocycloid and supertrochoid exercise. And this particular exercise is from the Graphics and Design Communication book by David Anderson, and it's question 12 on page 285. So to get started, guys, the question is here in front of you. You have a circle here that basically rolls around this path here, as you see, an inside or semicircle here of radius of 60 millimeters. The dimensions given here as well. The circle has a radius 25, and the point P here is 40 millimeters away from the center point of the circle, and you can see this distance of 80 millimeters given as well. So like all these questions, guys, I'm going to start off and I'm going to divide my circle into 12 equal parts that we can then use to represent each movement of that revolution. It does, state in the question itself, plot the locus of point P as the circle rolls clockwise for one complete revolution. So one full revolution it rotates for. So I'm going to go ahead, divide it into 12 equal parts, and we'll take it from there. There we go. I have the wheel divided into 12 equal parts. I suppose a question I'm often asked guys here is, where do you start with number one? Where does number one go? Is it up here, similar to the clock, or where? For me personally, I think the way I look at it is look at the wheel and the way it's going to roll, and which of those points is going to touch the, I suppose, the ground line or whatever line it's rolling on first. And that's what I usually start with as number one. So as this wheel rotates clockwise, this point here is the first one that's going to hit the ground. So for me, I go with that as number one. All right. So going to do the first part of this, guys. Keep in mind point P is outside the circle. I'm going to set up my center point here, the heights for my center point as I come across here and in around this fixed curve as well. And I'm going to set up my new center points, projecting the equal distance from 12 to 1 and so on. I'm going to plot those along here as well. So there you have it, folks. I have my numbers or my intervals or steps, whatever it is you decide to call them, done out along the bottom here of that fixed line and the fixed curve around here. So from 1 up to 12, I projected those in then to get the location of the center point as it moves along each step. And just to note on that, guys, you see here I got 6 full units, if you like, before I came to the curve. What I did then, where the curve here meets the straight line, I labeled that as point X. I took the distance from 6 to X and I struck that off here on the wheel, 6 to X. And that gave me a distance in from X to 7, which I can now transfer here on the fixed curve, X to 7. And then you're going with your full units there again up as far as 12. All right. So what I'm going to do next, we need to plot the locus of the point P, which as we can see is outside the circle. All right. So the same method applies here, guys, to previous exercise with cycloids and so on. You're using the method of triangulation. All right. So basically, what you need to be doing here is I'm going to take the distance from the center of the circle to point P. Right. And I'm going to use this compass to keep that distance at all times. All right. So what I'm going to do then is I'm going to swing an arc from my new center point number 1. I'm going to swing an arc there. Alright, so we're working on number 1 now. I'm going to then take my distance from number 1 on the circle up to point P. And I'm going to come down to number 1 on the baseline where it has rolled onto, and I'm going to swing an arc there as well. Now you can see there that haven't yet met, but I'm just going to re-swing that one. And sorry, going the wrong direction there. So just to be aware of that, the direction you're going in, just to make sure you're going the right way with that. With that there, my mistake, that's our P1 in its first position there. So where these two cross, that's P1, just going to label that in there using the method of triangulation. Alright, so as you see there guys, almost made a mistake, but I knew it was looking incorrect because I had gone in the wrong direction. So we know it's rotating clockwise here, so as it rotates, that's where your P1 is going to go. Alright, second one, move on to number 2, and again here my distance from center point to P. Moving on to my center point number 2, and I'm going to swing that arc. I suppose you're roughly gauging where you think it's going to be there. I'm going to swing that arc, quite a large arc, just for clarity. I'm going to get this time from number 2 on the circle, I'm going to set that distance to point P. Alright, so as number 2 rolls here, the circle down, it's going to come onto number 2 on the baseline. Here's your P2. Moving on to number 3, new center point. Swing that arc. Measure from 3 to P. From 3 on your baseline. And same with 4, 5, and 6. But that's it guys, up as far as the flat part is concerned. Alright, so I got my P1 right around to 2, 3, 4, 5, and 6. Alright, so to give yourself an idea where it's going to land guys each time, you could set your pencil here on point P in the center point and rotate it to give you an idea. Alright, as you're going through each motion, number 3 you could rotate and so on. Might give you an idea of the general direction it's going, and I'm just going to draw in that path of the point as it travels so far. So I'm going to move on now to the curved part of it. Alright, so moving on to the curved part here, where it takes a slight change guys from what we're doing. We are applying the same method, but it's just that we're working here off the curve rather than the flat line. So I already have my center points in, so we're going to apply the same methods. As I said, double check. You see I have 2 compasses here. I have 1 compass kept at that distance from the center of the wheel to point P. Alright, so moving on to center point 7 here guys, I'm going to set up my compass and I'm going to swing that arc there from center point 7, swing an arc in the direction, you know, you're kind of estimating for now where you think it's going to roll to. Alright, so swing that arc there from center point 7. Going to get my other compass here, set my distance from 7 to P, and I'm going to come down on the baseline here, or the fixed curve of 7, and I'm going to swing that arc there as you see it. So now that there is giving me point P7 here, which is quite close to P6 as you can see. Alright, sorry, P7. Moving on to number 8, same thing, just going to double check my compass. Alright, from center point 8, swing my arc. I'm going to swing a big arc here just to make it obvious, so you're going to have a lot of arcs at this stage, so you know, just to be able to keep track of them, I would label them as you're doing them. I'm going to take my distance now from point 8 up to point P. Alright, from point 8 here, swing that across that previous arc, and that there gives me point P8. Getting a bit muddled up there, but it should spread out now for the next few. On to number 9. Center point 9. Swing my arc. So I just came up with an extra here so I can identify that arc so I'm not getting mixed up. 9 to P on the wheel. 9 on the fixed curve, swinging by that arc. And that there is giving me P9. So I'm going to follow suit guys with 10, 11 and 12. using the same method and plotting the locus of that point. Getting on to number 12 here, guys, just to remember here, when you're swinging arcs, you might not necessarily think it's going right for you. But if you look down here, I'm moving on. I have P9, 10, and 11 done. The last one is number 12, all right? Now, I have swung my arc here at the radius from the center point to get that for number 12. But if you look down here, number 12 and number 12 and point P are directly opposite each other. So if I come from number 12 through the center point of the circle, out through there, that distance of 40 millimeters, that will give me point P. Okay, so I'm going to do that. I have my arc swung. I'm going to come out from 12 through the center point until it hits that arc, and that there will give me point 12. All right, so P12, and I suppose if you want to double check that, guys, that should be 40 millimeters from the center point. You can double check that, measure it there from my center point out 40 millimeters, and that looks correct to me there. My locus drawn in there, guys. I see there's a bit of a kick there from 6 to 7. Now I must double check that shape just to see, but because it's gone through a bend, there may be a bit of a kick in that there. I'd have to double check that. But just after checking that there, folks, I had made a slight error down here. As you can see the change, I had just incorrectly plotted point P6. All right, so I obviously just took a wrong measurement or so on and plotted that incorrectly. So it is a nice gradual turn there in that point P. And just to show you briefly there, a nice way of checking that, guys, is if you have a bit of tracing paper and just set that out over the wheel in its initial position. Okay, you see I have that plotted there. I have the point P on it. I have each division from 1 to 12 on it, and you can use that to check, guys, as that wheel is rolling, if your point P1 is in place. So the key thing here is, if you look at number 1 here, I'm putting number 1 down where it will be on the baseline, and the center point on the new position for the center point here, and that gives you point P1. Same thing, point P2, your center point in place and your point 2 in place, and that gives you the position of that, and so on. And that's the way I checked it, guys. For number 6, I checked that there just because it didn't look correct the first time. I put number 6 here on the baseline, put my center point into position, and there I saw I just incorrectly marked number 6. So that's a nice way of checking it. And you can see as it rolls around there, number 12. All right, center point in position, that gives you the final resting place of that. So no harm to have a bit of tracing paper with you. Trace the initial position of your wheel and point P, and you can move through it that way to double check, if you like, if everything is in order. So that's it for today, folks. We'll chat to you all again.